Welcome to Engage Math, Lesson 27, Problem 4. And this time we are continuing our work with graphing quadratic functions. And again, that means that our highest degree term is an x squared. That's what makes it a quadratic function. And we know that they graph as a u opening upward or downward. Okay, by the way, this form that we're working with today is called factored form or intercept form. You'll hear it called both. So the good news is that we could really quickly find our x-intercepts. Like, we don't have to do much math to do that. We know that x-intercepts put our graph on the x-axis, put a point on the x-axis. So the great news is the x-intercepts mean the y must be 0. Now, the only way that y is going to be equal to 0, the only way is if we could either get this parentheses or this parentheses to be equal to 0. Because if x minus 1 was 0, that would only happen if x was equal to 1. But think about why that's an x-intercept. If you were to put 1 in for that x right here, you'd have -2 times 0 times 4. But as long as that 0 is in there, it makes that entire right-hand side equal to 0, which means y is 0. So 1 is one of the x values that makes the y 0, which makes it an x-intercept. Let's do the same with the other parentheses. Think about what value you could put in for x that would make that second parentheses 0. And that's right, it would be a -3. So the reason this is called intercept form, often called intercept form, is because we can look at it and tell our intercepts, our x-intercepts are at 1, -3. We can look at that equation and tell that right away. So we have those two values and now the vertex. So the interesting thing about parabolas is they are always symmetric about the highest point or the lowest point. And that highest or lowest point is called the vertex. So in this case, the x-coordinate of our vertex is going to be the average or the middle of 1 and -3. Now you might be able to look at that and tell the number halfway between the x-coordinate of 1 and -3 is -1. So you might be able to look at it and tell, but if you can't, no problem. What you're going to do is you're going to say 1 plus -3 divided by 2. We're basically taking the average of 1 and -3. And the average of 1 and -3 is going to be a -2 over 2, which is -1. That's how we get the x-coordinate of the vertex. But the issue is we don't know where to put that -1. We don't know where the vertex is. It's somewhere on this line, x equals -1. And by the way, I'm going to fill this in right now because we know that the line x equals -1 is going to divide our graph into two symmetric parts, otherwise known as the axis of symmetry. So I kind of have that dotted in, but how are we going to find the y-coordinate of the vertex? Well, the good news is it's going to be not that challenging because we have this awesome formula right here, this equation. And all we have to do now is say, okay, we're looking for y, and we know what x is. So y equals -2 times -1 minus 1 times -1 plus 3. Notice that what I'm doing is putting -1 in for each of the x's. So I'm going to simplify it here. So y equals -2 times -2 times +2. And when you multiply all those together, you're going to get a +8. So the x-coordinate is -1 and the y-coordinate is a +8 of our vertex. So here's our vertex is right here at -1, 8. So we can already see what the graph looks like. But in this problem, they're also asking us for the y-intercept. So let's find it. We know that to have a y-intercept, x is 0. It's the only way we're going to end up on the y-axis is if the x-coordinate is 0. So let's go back because this is a great habit to be in. The way you find the y, just like we did in part B to find the y-coordinate of the vertex, is to put 0 in for x. So we have y equals -2 times 0 minus 1 times 0 plus 3. And that's going to give us y equals -2 times -1 times +3, which is going to give us a +6. So we know that the y-intercept is at 0, 6. And if you want to, you can go on the other side of that axis of symmetry. And we know there must be a point at -2, 6, even though it wasn't asked for in this case. And here is our parabola. Great job. See you next time at Engage Math.